makes an object move? What makes it stop? Did you know right now your body is being pushed, pulled, and pinned by something super strong that you can't even see? Most people don't realize it, but every object on Earth goes through an invisible game of tug of war every second of every day. We get into all about forces in motion right now. Let's first start off by talking about forces. What is a force? Put very simply, a force is a push or pull. If you pull open a door, you're using a force. If you push your friend, first of all, that's not very nice, but you are also using a force. Forces make objects move. Like if you see a ball just sitting there on the ground, not moving, and you kick it, you are the one making it move using a force. Forces can also make objects stop. Like if a friend throws a ball to you and you catch it, you are making that object stop. Not only can forces make objects move or stop, they can also make objects change direction. If an object is already moving, a force can also change its course or the direction that it's moving in. Take a look at this ping pong ball, for instance. The force of the paddle redirects or changes what direction the ball is moving. Forces come in two types. We have contact forces, where the objects are physically touching one another. And we also have non-contact forces. That's when the objects do not need to be physically touching for the force to still have an effect. Let's talk about two invisible but extremely strong forces we deal with every day. I'm talking, of course, about gravity and friction. Let's first talk about gravity, which is the constant pull from the Earth. Now, as I said, it's constant. It's always happening. It never lets up. It's relentless, all right? Earth is constantly pulling every object on it toward its center, or in our case, the ground. Now, if we didn't have gravity, we would simply go flying off into space, which would not be fun. It might sound fun, but it wouldn't be. Whee, I'm in space. Woohoo, this is fun. Wait, there's no air. Oh. Every object has its own gravitational pull, but the size of that pull depends on the mass of the object. Now, humans actually do have a gravitational pull, but it's very, 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 very small. All right? And Earth has a mass that is much, much greater than that of humans. So Earth's gravitational pull is much, much, much greater. Gravity is an example of a non-contact force, which is a force that works without physically touching the object. Now, if I were to throw a ball in the air, it would still be pulled back down to Earth by gravity, even though it's not actually touching the Earth. Okay, now let's talk about friction, which is a contact force when objects touch one another physically. Friction happens when objects rub together. Friction is the enemy of speed and motion. It is constantly trying to slow things down. It's kind of like Harry Potter and Voldemort, or fire and water. They are enemies, and they do not coexist. They want different things. Speed and motion want to go fast. Friction wants to be like, hey, slow down. Slow down, you. Smooth surfaces, like ice, have lower friction, where rough surfaces like grass have higher friction. If you ever try to hit a hockey puck over some grass, you're going to have a bad time. Now, objects can have multiple forces acting on them at the same time. When you play catch with a friend, the ball you throw is actually battling two forces at once. It's battling gravity, which is constantly trying to pull it back down, and it's encountering friction as it moves through the air, which is constantly trying to slow it down. But what about in space? Now, in space, there is no air, so there's no friction in the air for the ball to run into. If you threw a ball in space, it would continue on that same path at that same speed forever, or at least until it was grabbed by another larger object's gravity. A long time ago, a scientist named Isaac Newton came up with rules, which we now call laws, to help explain how objects react to forces in motion. In his first law, Newton says that an object at rest, or still, will stay at rest unless acted on by another force. He also said that an object in motion will stay in motion unless acted on by a force. Now let's talk about Newton's third law, which says that forces come in pairs. They're like twins who push in opposite directions. Newton's third law states that for every action, there is an equal and opposite reaction. When you throw a ball at a wall, it actually pushes back at you with the same amount of force that you threw it. This is how birds fly and rockets take off. They push against the ground or down, lifting them up. The most famous example of this is in an object called Newton's cradle, named after Isaac Newton himself. The swinging ball slams into the ones that are at rest. The ones at rest push back and stop it, but not before the energy is pushed to the ball all the way on the other side. Okay, let's recap real quick. A force is a push or a pull. There are contact forces and non-contact forces. Gravity is the force that pulls us down. Friction is the force that slows us down. Newton's first law states that an object at rest or an object at motion will stay that way unless acted on by another force. His third law says that for every action, there is an equal and opposite reaction. All right, everyone, thanks for watching. See you next time.